going to do two more examples of using product and quotient rules of exponents. The first one is a product rule, so 3x to the fourth times negative 2x to the fifth. And the second one is a quotient problem, so I'll use quotient rules, 15y squared divided by 3y to the eighth. Sometimes when I'm teaching rules of exponents, I use this, MADS. I say exponents make me really mads. And the reason I do this is that it helps students remember the rules when you don't just have exponents, but you have exponents with coefficients and you're multiplying things. So if I'm multiplying monomials, I'm going to use the MA part of the MADS rules. I'm going to multiply the big numbers and add the little ones. Multiply the coefficients and add the exponents. So this first problem, 3x to the fourth times negative 2x to the fifth, I'm going to multiply the coefficients. So 3 times negative 2. And 3 times negative 2 is, of course, negative 6. And then I'm going to add the exponents. So I'm going to add the 4 and the 5. And remember, I can do that because the bases are the same. The x's are the same base. So 4 plus 5 is going to be 9. And here's a mistake that some people do. They just write down the exponent, but you really need the base here, right? It's x to the power of 9. I've got 9 x's altogether in that problem. There's the answer, the simplified answer, negative 6 x to the ninth. Now let's look at the D part of the MADS rule, the D and the S. So like when I was multiplying monomials, when I'm dividing monomials, I'm going to divide the coefficients. So the big numbers, or the coefficients, I'm going to divide. And then I'm going to subtract the exponents. So we'll divide or subtract the 2 and the 8. I'm going to rewrite this as a fraction problem because we've been thinking about division set up in a fraction kind of way here. So fraction format, 15y squared divided by 3 times y to the 8. So let's divide those coefficients first. 15 divided by 3, that's just going to be a 3, no, a 5, sorry. And then 2 minus 8 is going to be a negative 6. Y to the negative 6. And then I could leave it like that, but I think I will use my negative exponent rules and move that y to the 6 into the denominator. The 5 stays on top, right? The 5 isn't being raised to the negative 6 power, so the 5 stays right where it is. It's the y to the 6 that gets moved down. There it is. 5 over y to the 6.